our final lesson on trigonometry. Next week, we're going to go back and we're going to do just a quick recap of Euclidean geometry so that it's in line with what it is that you guys are doing at school. And then we will move on to analytical geometry. Okay, so identities. This is now where things in Trig start to get a little bit more complicated, but there are some tools and some things that we can use in order to be able to help us prove identities. Again, we're not allowed to use calculators in this section, not that we need to, we're not actually calculating the value of anything, but yeah, still no calculators. Some strategies that you can use to prove identities. The first thing that's important for us to understand is that when you are proving an identity, you are not solving an equation. All right. So it's not like if they give you something like 2x plus 3 equals 9, it's not like they're asking you what the value of x is. So because you are not solving an equation, you cannot work with the left-hand side and the right-hand side of the identity. All right. You've either got to work with the left or with the right, but you have to do it independently of one another. Okay, so in other words, you would take the left-hand side and you would work with it, or you would take the right-hand side and you would work with it, but you cannot keep the equal sign in the middle and work on the left-hand side and the right-hand side simultaneously. Okay, that's the first thing. Okay, because what you are doing, you're not calculating the value of something. What you are doing is that you are proving that the one statement that you've been given is equal to the other statement. So in other words, when we're doing an identity, we actually already know what the answer is. What the teachers and the people that are marking our work are looking for is they're looking for the steps in between. Okay, so that's what our focus is on here, is how do we get from the left-hand side to the right-hand side, or how do we get from the right-hand side to the left-hand side, first of all. The other thing that's important for us are our identities from grade 11. Okay, so if we recall our tan identity, so whenever we see tan theta, we would write it as sine theta over cos theta. That's really important. And our square identity. So these are our identities from grade 11. So sine squared theta plus cos squared theta is equal to 1. Okay, so a lot of the time what they will do is they will give us the 1 and we would need to write it as sine squared theta plus cos squared theta, and you're going to see that this evening. Okay, I'm going to show you how we would use that. Okay, our double angle and compound angle formulae, which I have available for us when you try these questions, so you've got to be looking out for those as well. So we're often expected to expand a compound or double angle formulae in order to be able to simplify, etc., etc. And then something else which I'm going to focus on more towards the second part of our lesson this evening is the addition and subtraction of fractions. Okay, so that's whoever would have thought that that would become important for us now while we're in matric, but very, very important. So adding and subtracting of fractions. So just very, very briefly before I get started, right? When we add and subtract fractions, you have to find a lowest common denominator. So for example, and I know this is a very, very basic example, but let's say if I had 2 over 3 and to that I wanted to add 1 over 5. Right? I can't add or subtract fractions when the denominators are different. So I need a lowest common denominator. All right, so in this case, what number would I use as my lowest common denominator? Matrix. There we go. Okay, so my lowest common denominator would be 15, absolutely. So essentially what I'm doing is I'm creating two equivalent fractions, both with the denominator of 15. And I would do that by multiplying that by 5 and that by 5, and that by 3, and that by 3. Okay, so I'm going to end up with 10 over 15 plus 3 over 15. And then what's the next step here? What would I do now in order to simplify it fully? Can anybody tell me? What's the next step when I'm adding fractions together, matrix? Add the 10 and the 3. Cool. There we go. All right. It's literally as simple as that, except we're going to be doing it with trig expressions. So I'm going to add my numerators and I'm going to keep the same denominator. Okay, so just bear that in mind when we get into the questions that have got fractions in them. Okay. All right. And then the other really, really, really important thing for us, I know this is a lot to sort of digest at the beginning of the lesson, but we can't really do this without going through these things, is being able to factorize. Okay, so let's just pick a different color here and we'll just highlight the word factorize. And of course, we know by now that there are many different ways in which we can factorize expressions. So either we can take out a highest common factor, or in some cases, we can work with the difference of two squares, or we can factorize trinomials. Under some very, very unusual situations, we could see grouping or sum and difference of two cubes. But I must be honest with you, I've never seen sum or difference of two cubes in a trig expression. Not to say that it doesn't exist or it couldn't happen. I've just never, ever come across a question with that in it. All right, now, the reason that we have to be able to factorize is because we want to simplify. So again, just before we jump into things, I just want to talk quickly about why factorizing is important. If I make up a question, let's say I say 2 plus 3, and then here at the bottom, I say 5 plus 3. If I come along, now what I'm about to do is very, very wrong. Okay, I'm going to say that again. What I'm doing now is very, very wrong. Okay, but if I mistakenly canceled out the 3 at the top and canceled out the 3 at the bottom, the reason why it does not work to cancel over plus or minus signs is because you don't get the same answer. All right. So in other words, if I cancel out my 3's at the top and at the bottom, I'm saying the answer is 2 out of 5, which it actually isn't. If I did this question a different way, though, I would say 2 plus 3 in the numerator, that would give me 5, and 5 plus 3 at the bottom, and that would give me 8. Are 2 over 5 and 5 over 8 equivalent fractions? Is 2 over 5 the same as 5 over 8? Is that true? Or is it true? No. Yes, and I like the capitals in Flanta. Definitely not. Yes, no, it's definitely not true. Okay, so that's why you cannot cancel over plus and minus signs. I know this is a very simplistic way of putting it, but that's the reason behind it. Okay, it's because we're not going to get the same answer. Now, when we factorize, what we are doing is we are creating factors. We don't have terms anymore. So 2 and 3 are two separate terms, and 5 and 3 in the bottom are also two separate terms. So now if I have 2 times 3 at the top, 2 and 3 are now factors, they're not terms, and I have 5 times 3 at the bottom. Now, either which way I do it, whether I cancel or whether I multiply first and then cancel, I am going to get the same answer. Okay, so let's say I come along and I decide to cancel first, 3 at the top with 3 at the bottom. That would give me 2 over 5. If I did this, sorry, I haven't given myself much space here. Let me just rub that bit out. If I do it a different way, I'm still going to get 2 over 5 because 2 times 3 is 6, 5 times 3 is 15. Are 6 over 15 and 2 over 3 equivalent fractions? Yes, exactly, precisely. All right, so 6 over 15 is 2 over 3. All right, so do you see why we need to factorize? Because we cannot cancel over plus and minus signs. So the minute you see pluses and minuses, that's quite right, Hugo, then we can cancel. All right, so just bear that in mind as we go through all of this. And hopefully what I'm doing here will become apparent to you. Okay, let's jump into our first example. And here we are asked to prove that 1 minus cos 2 theta over sine 2 theta is equal to tan theta. So we can see what we have on the left, which is the 1 minus cos 2 theta over 2 theta, and on the right we have tan theta. Most of the time, matrix, and I use the word most, okay, because it's not the same for every single identity. Most of the time, what you are doing is working with the left-hand side and simplifying it to the right-hand side, okay? Sometimes we can work with both sides as long as we don't work with them at the same time when they're equal to one another. I think I've got an example like that here as well. All right, so what I'm going to do is I'm going to write here left-hand side equals. Okay, so I'm splitting them up. 1 minus cos 2 theta over sine 2 theta. Okay. This is where things start to become a little bit more difficult, right? How do I know how to write cos 2 theta? Because if I look at my compound angles and my double angle formulae, I've got 3 options here. I've got 3 different ways in which I can write cos 2a. So what I want to try and go for here is something that is going to cancel out the 1. All right. My other option, of course, is to write one in a different way, but this is going to be quicker for me. I can write one as sine squared theta plus cos squared theta, but it's going to be easier for me to write cos 2 theta in such a way that it cancels out the 1. So what are your ideas here, guys? How do you think I should write the third way? I agree with you, Palesta. Thank you so much. The last one, indeed. Okay, I want to get rid of that one. Because remember, I'm trying to simplify. I want it to come down to one term. So I want to get rid of as many terms as I possibly can. Again, good maths. I've got a minus, so I must use a bracket. And I'm going to put my 1 minus 2 sine squared a inside my brackets, and that's going to go over sine 2a. And sine 2a or sine 2 theta is an easy one to work with because there's only one way in which we can expand that, and that's to write it as 2 sine. Sorry, I'm being naughty here. Look at this. I'm writing a there instead of theta. Sorry, guys. Let me just fix it up. 2 sine theta cos theta. Okay, now I can get rid of my brackets. Okay, so 1 minus 1 plus 2 sine squared theta. So I'm distributing that negative into the brackets over 2 sine theta cos theta. So now you can see at the top, I originally had 2 terms. I removed the brackets. Now I've got 3 terms. The 1 minus the 1 cancels out, and I am left with 2 sine squared theta over 2. Sorry, I'm trying to write small because, as always, I use far more space than I ever think I'm going to. Let me just move that down. Okay. And at the bottom, I've got 2 sine theta cos theta like that. Okay, so I only have factors. Okay, so what I'm seeing here now, it's like me with the 2 times 3 over the 5 times 3. I'm allowed to cancel over multiplication and division signs. So 2 divided by 2 is going to give me 1. Sine theta will go into itself once. It'll go into sine squared theta, sine theta number of times. And there we go. Our answer is starting to emerge. We've got sine theta over cos theta. And we know from our tan identity that sine theta over cos theta is equal to tan theta, like so. Okay, so before we take any questions, I just want to show you where your marks would be awarded, okay? Very important when you're working with double angle formulae and compound angle formulae, you're going to get marks for using those formulae. So here there would be a mark for writing 1 minus 2 sine squared theta. There would be a mark for that one over there. I imagine there might be an accuracy mark over here on simplifying. What they're not going to do, Matrix, is they're not going to give you a mark for the answer because that's obviously been given to you at the beginning of the question. All right. Are there any questions? Any questions, Matrix? Sure. Are we all happy? Are we all ready to try one ourselves now? Okay. All right. So thumbs ups. Okay. All right. Cool. Thank you, Andile. All right, slacker. Now, time for you guys to try one. Let me just go and get this because you're gonna need that. Okie dokie. So here is one for you guys to try. Okay, so either you can try A or you can try B. If you are a fast finisher, then you're welcome to try both of those. All right, so we're going to give you a little bit of time. You try either A or B. I'm leaving it up to you. Remember, when you square a binomial, you're multiplying the bracket by itself, okay, matrix? Okay, and then when you're finished, or you think you're finished, you can pop done or a thumbs up or something like that into the chat for us. Okay. And any questions, please ask either Hugo or I. Well done, Chiamo. No one else seems to be finished yet, so maybe try B while we're just waiting. Okay, cool. Well done, Onwaba and Zintle and Lesejo. Good job. Well done, Khatliso. Well done, Dimple. Nice, Nobasutu. Yeah, hopefully A wasn't a bad one. Yeah, absolutely. Yeah, if you've done A, like Hugo says, try B, just until we've had a few more people say that they're finished. I'll just give you guys a couple more minutes. Like with everything in maths, I know we tell you this all the time, and I'm sure you must be so irritated with all the grown-ups saying the same thing, but it's so true. The more you practice, the easier it becomes. Well done, Beatrice. Cool, Emmanuel. Well done, Nhlanhla. Good, Chioma. Well done. Cool, Nadia. Good, Tato. All right, so we're going to go through the answers to these, and then we're going to move on and do something that you got them. Nice one. Lovely. Well done, Matrix. Done with both. Okay, cool. Then I think it's time for us to move on, as a lot of you are saying that you've done both. All right, beautiful. Who's feeling brave and wants to tell me how they did A? Or share with us how we did A. Let me just move this stuff down. Chiamo, go for it.
Ma'am, at A, I did the left-hand side.
Mm-hmm.
I splitted the two brackets.
Okay. So did you write cos theta plus sine theta in brackets, and then you wrote another bracket and you had
Yes, ma'am. I did
and
that.
okay, cool. Then keep going.
And then I said cos theta times cos theta is cos squared theta
Excellent.
plus sine theta cos theta plus
Cool.
sine theta cos theta plus sine squared theta.
Fabulous.
And then I said 1 cos squared theta plus sine squared theta is 1. And then sine theta cos theta plus sine theta cos theta is 2 sine theta cos theta. And then afterwards, I said, therefore it is equals to the right hand side because 2 sine theta cos theta is sine 2 theta.
Beautiful. Okay, that was absolutely perfect. Well done. So it equals the right-hand side. You don't have to write that it equals the right-hand side down there at the bottom. You're not going to get any extra marks for that. Okay, but really nice. You expanded your brackets beautifully, collected your like terms, and then used your double angle, the reversal of the expansion. Very, very good. Well done, Shyamo. Thank you so much for sharing your answer. Okay, who's going to do B first? Who's feeling brave and wants to do B? Yeah, go for it, Andile. Andile, you're welcome to.
Yes.
Oh, Andile, just give me 1 second, just 1 second. Nadia, just so that you guys, just 1 second, Andile, don't go anywhere. Okay, so Nadia, where would the marks be awarded? Okay, well, you would definitely get a mark for expanding your brackets, then using your identity, so going cos squared theta plus sine squared theta is 1. And then here, I think for collecting the sine theta cos theta and getting that. Okay, I think that's where your marks would be awarded. Okay, Nadia. All right, Andile, it's all yours. What did you
Yes.
write?
I did B, and I
Okay,
dealt with the left-hand side.
okay.
Yeah, and since the rule for cos 2x or theta, right?
Mm-hmm, mm-hmm.
It says cos square theta minus sine square minus theta. I used that, and then
Cool.
for the bottom part of the equation, I didn't change it. I left it like that, to cancel the top part to get my answer, which was equivalent to the right-hand side.
Okay, so did you start cancelling at this point where I am now? So you cancel cos with cos and sine with sine. Did you do that?
Yes.
Okay, all right. Now, I'm very, very glad that you've done that, okay, because it's wrong.
Okay.
Okay.
Yes.
All right, so I'm very pleased that you made that mistake because now I can help you to correct that. All right. Do you
Mm-hmm.
recall earlier we were talking about how you cannot cancel over plus or minus signs? Do you remember me saying that? So I used
Yes.
an example. I think I said 2 plus 3 over 5 plus 3, and I canceled the 3 at the top with the 3 at the bottom. Do you remember me doing that?
Yes, I remember.
Okay, you remember that. And then we agreed that 2 over 5 was not the equivalent of what did this end up being? It was 5 over 8, right? It
Yes.
would be exactly the same thing with this. So you are not allowed to cancel because of these minus signs over here. I know it's tempting, but the minus signs are what's stopping us from doing that. Okay, so what you
Yeah.
have to do is you have to factorize before you cancel. All right, now what you've got here is you've cracked the first line of the problem, which is brilliant. In maths, most of the time, that's what you need to do. If you can crack the first line, the rest of it just kind of flows. So I don't want you to have done something like this, pick the correct identity, and then have lost marks because you cancel terms instead of factors. So now what I want you to do is look at your numerator and tell me what sort of factorizing do you think that is?
Mm,
What are you looking at there in the numerator? What sort of factorizing is that? Any idea?
no.
Okay, how about if I wrote this? What if I wrote, what sort of factorizing is that? Do you recognize that?
Expressions.
Yes, so if I wanted to factorize a squared minus b squared, I'm not going to take out a negative, Nadia, although that is a good suggestion. This is not as I'm going to use an identity here. This is dots. Remember difference of two squares?
Mm.
Okay, so when you factorize difference of two squares matrix, your brackets are, for all intents and purposes, identical, but the sign in the middle of the bracket is different. Does that ring a bell? All right, so we would do exactly the same thing here. In one bracket, we would have cos x plus sine x, and in the other bracket, we would have cos x, sorry, my handwriting is terrible this evening, minus sine x, like so. So I've factorized difference of two squares. And I'm doing that because now I am allowed to cancel. Essentially, that's got brackets around it as well. And now I can cancel a bracket at the top with an identical bracket at the bottom.
Oh, okay.
Okay,
Now I understand. Thank
okay.
you.
Pleasure, no problem at all. And here we go. We've got to our answer. We've got to our right-hand side. So cos x plus sine x, and now our left-hand side does in fact equal our right-hand side. Okay, and again, where would our marks be allocated for a question like this? Definitely on using that identity. And that was the right one to pick in this instance. The other two would not have worked. Okay. And then definitely for factorizing. And I think that's probably all we would get marks for in a question like this one. Maybe a mark on simplifying, but probably not. Okay. Are there any questions before we move on to something that's a little bit more difficult? How are we all feeling at this point? Are we thumbs up, thumbs down? Are we feeling good? You made the same mistake. Tatu, it's wonderful. Okay, mistakes are how we learn. Okay. I'm so glad you made that mistake, and I'm so glad that we could talk about it. Okay, good. There's some thumbs ups. See, there's two hands up before I carry on. Mbulelo, do you want to ask a question, Mbulelo? You're welcome to unmute and ask, Mbulelo.
I was wanted to do number B.
Oh, did you? Oh, my apologies. I'm going to give you a chance later on, and if you want to answer one of those, then please do put your hand up again, okay? Sorry, Mbulelo.
Okay. All right,
Sorry.
ma'am.
Okay. Dimple, did you want to ask a question?
No, ma'am.
Sorry, Dimple, I couldn't hear you.
I understand. I made the same mistake.
Did you make the same mistake? That's lovely. I see there's a few people that are putting it in the chat saying that they made the same mistake. So that's a really, really good thing that that came up. You see, and this is why you mustn't be afraid of sharing what you think and what you've done, because you're not going to be the only person that made that mistake. And then we all learn together what the right thing is to do. Okay. All right, cool. I feel good about that. I hope you guys do as well. Let's have a look at the next example. Okay, so now this, as I said to you a little bit earlier, this example is going to be a little bit more difficult. All right. And what I'm also doing here is I'm also throwing in a question where we have to calculate the value of something without using a calculator. And we spend quite a lot of time doing questions like that when we were doing our compound angles and more specifically our double angles. So I wanted to bring this specific concept in here as well, because they love to do this in Trig, where they get you to prove something and then they ask you to work with it a little bit further. Okay, so let's have a look at what they've given us here. They want us to prove that 1 plus sine 2a over cos 2a equals cos a plus sine a over cos a minus sine a. So again, we realize it's an identity. We're going to split the left-hand side and the right-hand side. So let's do that first. 1 plus sine 2a, let's just get it down on the page, over cos 2a. Right, now, when we were working in this example over here, I encourage you guys to use an identity for cos 2 theta that would get rid of the 1. Here, we've got a 1 as well, but we've got it with sine 2a. So it doesn't matter what we combine the sine 2a with. Well, no, actually, that's not coming across correctly. There's only one way for us to write sine 2a. So there's not an identity that we can pick for sine 2a that's going to cancel out the 1. So that 1 is not going anywhere. It's staying in the question. All right. If you had a look up here, which is why I included this question as well. On the right-hand side, we had 1 plus sine 2 theta, right? 1 plus sine 2 theta, if you recall, it was equal to 1 plus 2 sine theta cos theta, and that came from this trinomial. Now, this is a very important thing to know and to learn, okay? 1 plus sine 2a, when they see that, what they want you to do is they want you to write sine 2a as 2 sine a cos a, and they want you to change the 1 into cos squared a plus sine squared a. All right. So let's go ahead and go and do that. So I'm going to write my 1 as sine squared a plus cos squared a. And I'm going to write sine 2a as 2 sine a cos a. All right. At the bottom, I don't really know what to do with my cos 2a. I've got 3 options, remember. I don't know which one I'm going to pick. All right. It could be, let's just grab that and bring it down. Oh, it's got one there as well. Just stick it here for you guys so you can look at it at the same time that I'm speaking. All right. I've got 3 options here. I've got cos squared a minus sine squared a. I've got 2 cos squared a minus 1. I've got 1 minus 2 sine squared a. But if I'm looking carefully at my I nearly said inequality, at my identity, I can see that on the right-hand side, I've got cos a plus sine a at the top, and I've got cos a minus sine a at the bottom. Which one of the 3 do you think would be the best? I mean, if I use that as a guideline or as a clue, there we go, the first one. Quite right, the first one, absolutely. So we're going to write cos 2a as cos squared a minus sine squared a. Now what I'm going to do is I'm going to rearrange my numerator a little bit. Okay, I don't know if you can see this yet, Matrix, but it's becoming a trinomial. So let's just get rid of that. Again, I don't give myself enough space. I don't know why I don't learn this, but anyway. All right, it's becoming a trinomial. What I'm going to do is, because I can see that I've got cos A first in both terms on the right-hand side over here. So what I'm going to do is I'm going to put this term, this cos squared A term, the one that's in the middle, I'm going to put that at the front. This plus 2 sine A cos A, that's going to be my middle term. And sine squared A is going to go at the end. Oopsie, there we go. And I'm going to have that over cos squared A minus sine squared A. Now, I see there's a lot going on in the chat. I'm just going to stop and have a look at what you guys are saying. Yes, now we're going to factorize the numerator. Quite right. Absolutely. So in Tlantla, how am I going to factorize the numerator? What am I going to write? What would you write if it was you? What?
Ma'am, I would put the cos A plus sine A brackets.
You're right. Keep going.
Is it cos A again, ma'am?
It is. Absolutely. And then what sign do you think goes next?
Amen.
Okay.
I'm
So
lost on that.
oh, it's all right. Don't stress. Okay, so now you've got to be very careful here, Matrix. All right, and this is where, yes, and Waba, you're quite right. So Sharon, I know you've said minus. Ayanda, you've said minus. Nadia, you've said minus, and I understand why, because we've just done a question like that, right? Where we factorized difference of two squares, and one bracket had a plus and the other one had a minus. I understand why you guys are saying that. But you've got to remember, at the end of the day, we are using our algebra, right, when we work with these. So let's just go through that very, very quickly. If I have a squared minus b squared, that is difference of two squares. So when I factorize this, it factorizes into two brackets that are the same, but the sign in the middle is different. What's missing from a squared minus b squared is the middle term. The middle term is equal to 0. Remember, if you were going to multiply this out, okay, you're going to do FOIL, you'd end up with a squared minus ab plus ab minus b squared. Okay, so these terms in the middle, they add up to 0. When you are working with a trinomial, okay, so in other words, if I've got a squared plus 2ab plus b squared, all right, now I've got a middle term over here. Okay, it's also not a difference of two squares, but what I've got here is a plus b, and then here I've got a plus b. So this is a perfect square trinomial. Right, do you see the difference between the two? Okay, so the one is difference of two squares. So this, when it factorizes, is difference of two squares. But what we have in our numerator over here is not difference of two squares. It is a trinomial like this purple one that I've got on the right. So that's why in this bracket over here, I've got to have plus sine A. It is a perfect square trinomial. Okay, there we go. So a lot of you are now saying plus. Yes, perfect. Over cos squared A minus sine squared A. Now I'm going to factorize difference of two squares. So here I'm going to have cos A plus sine A. And then in the other bracket, I'm going to have cos A minus sine A. So two different types of factorizing matrix. In the numerator, you've got a perfect square trinomial. In the denominator, you've got difference of two squares. Okay, and then remember, we can only cancel something at the top with something at the bottom if they are identical. So I can't cancel cos A minus sine A with anything, but I can cancel that guy and that guy over there. And hopefully now I've got what I had on the right-hand side. So cos A plus sine A over cos A minus sine A, like so. And let's just go back and go and check. There we go. All right, so we've got that correct. Are there any questions before I do the next bit? Are we feeling okay? Okay, Lisa, that's a very good question. A lot of people ask that question. All right, so not Wazzy. All right, so where did 2 sine A cos A go? It didn't go anywhere. I factorized. All right, so if we're going to ask that question, where did 2 AB go? Okay, so it didn't actually go anywhere, did it? What I'm doing is I'm rewriting my expression in a different way. So when you factorize, you're starting with terms and you're ending with factors. It is the putting in of the brackets. All right, so that 2AB didn't go anywhere. I factorized my expression. Does that make sense? Zintle? Are you not enjoying this? I know this is difficult. I know this is difficult. Oh, Siam Tanda, I'm so sorry. Is there something that I can explain better? Can you give me a specific thing that you didn't understand where I lost you that I could maybe go over again? Please do one more example like this one. Yes, I've got absolutely. So I've got a question that is very similar to this down here for you. All right, for you guys to try. If you want me to do it with you rather than get you to do it on your own, I'm more than happy to do that. Okay. Zintle, ma'am, can we go over where you swapped? When you say I swapped, what do you mean that what do you mean by swapped exactly? Sure, Faheen, no problem. Zintle, go for it.
And also where you like rearrange the equation.
Okay, so when you say rearranged, do you mean from the second line to the third line?
Yes, ma'am.
Okay, so in other words, do you understand? Are you okay with the idea that I took the 1 and I wrote it as sine squared A plus cos squared A? Does that make sense to you?
Perfect sense, ma'am.
Perfect sense. Okay. And then you're also happy with the idea that I took sine 2A and I expanded my sine double angle and I wrote it as 2 sine A cos A. And then
Yes,
you're
ma'am.
also cool. And then it's also okay that I took cos 2A and I wrote that as cos squared A minus sine squared A. Is that all right?
Yes, ma'am.
Okay, all right. So now what I've done from the line that I've highlighted with the pink and the purple and the blue is I have rearranged those 3 terms. So what I've done is I have taken the cos squared A that was in the middle and I've written it first over here. Then I've taken the 2 sine A cos A and I've put that in the middle. And then I took the sine squared A over here and I put that at the end. Now, the reason that I'm doing that is because I'm trying to make myself a trinomial that I'm going to factorize. Okay, I know that on the right-hand side, Cos A is the first term, all right, at the top, and cos A is the first term at the bottom. At the top, it doesn't matter because cos A plus sin A plus cos A, it's the same thing. But when you're subtracting, the order does matter. But so I want cos A at the front. Okay, so that's why I put cos A at the front over here. Then what I was trying to do is I was trying to get you guys to understand that cos squared A plus 2 sin A cos A plus sin squared A, if I could swap cos A, so in other words, if I said let cos A be x, and if I said let sin A be y, I can write this expression at the top here in terms of x's and y's. So it would be x squared plus 2xy plus y squared. Okay, which is something I'm sure that you would have seen at high school before. Okay. Then we were
Yes.
talking about how would we factorize this? So this is what we refer to as a perfect square trinomial. So a bracket times itself gives us this trinomial. So if I was going to factorize this, I know that I've got to have x at the front here, and I've got to have x at the front here as well, don't I? In order to get the y squared at the end over there, I'd have to have y times y. All right, now to get my middle term over here, my middle term comes from the outer and the inner terms. So x times y, it would be xy, plus x times y would be xy. That would give me my 2xy in the middle. It's exactly the same idea as what I've done over here in this line where I'm putting the pink star. Can you see that now?
Yes, ma'am. Yes, ma'am. I see.
Does that make sense to you? And then at the bottom, I've done a different type of factorizing. So this at the top here was my trinomial. This at the bottom here, that's not a trinomial. This is difference of two squares. So just how I factorized earlier, where if I had a squared minus b squared, it factorized into two brackets, a plus b in the one bracket, a minus b in the other. So it would be the same thing over here. That's why I've got cos a plus sin a, cos a minus sin a. All right, and then once I've got that, once I've factorized, only then can I start canceling something at the top with something at the bottom. And then what's left over is what I've brought down to the next line. Okay, there we go. Hugo's putting it in. Yeah,
Yes, ma'am. Thank you.
yeah, no problem. Let's just see what you guys are saying here. Okay, so Sharon, it's exactly what Hugo was saying. All right, so it's not the same thing. If you've got minus AB plus AB, that's different to AB plus AB. So the one adds up to, or if you use X's and Y's, it doesn't matter. If you've got XY plus XY, that's how you're going to get 2XY. But if you've got minus XY plus XY, then you're going to end up with 0. Okay, so that's the difference. Yeah, absolutely. And Klanta, we're going to do another question. All right, well, then I tell you what, maybe what I must do is I'll leave the second part and let's try and do this question over here. All right. So proving that sine 2 alpha over 1 plus cos 2 alpha is equal to tan alpha. Might be a little bit easier. Right. Just looking at the time, I wonder if it would be better for me to do this with you guys then. I have got more questions like these that you can try and practice on your own. Like that one over there is another one that's gonna give you guys a bit of a challenge. Okay, so if we have a look at number 1, we've got sine 2a over 1 plus cos 2a equals tan a. All right, so can anybody tell me what do you think we should do with the numerator? What are we going to do with the numerator matrix? Okay, cool. Cool, good, well done. And what do you think we're going to do at the bottom? Okay, so you can't leave the numerator as is because you've got a double angle there in Tlantla. So you've got to rewrite your double angle using your double angle identity. Okay, so if you see sine 2 theta, write it as 2 sine theta cos theta because at least you know you can get a mark for that. Okay, what do we think we should do at the bottom? Okay, what do you want to do with the 1? How do you want to rewrite the 1? Do you want to want to rewrite it in a different way? What do you, Zintle? What do you think you should do?
Maybe Mami could write it as cos squared A plus sine squared A.
Okay, if I wrote it, I'm going to do what you say. I'm going to write it as cos squared A plus sine squared A. What would you then do with plus cos 2A at the bottom? How would you rewrite that?
Use cos squared A minus sine squared A.
Okay, so I'm going to write it as plus cos squared A minus sine squared A. All right, cool. So then in our second line, we would end up with 2 sine A cos A over what would we have at the bottom? What would we have left over at the bottom, matrix? You could do that, Nolwazi. That would also work. Absolutely. Go for it, Zintle. What would we have at the bottom now?
Won't the sine squared A and negative sine squared A cancel each other out? Then we'd have 2 cos squared A.
Lovely. Keep going.
Okay, 1 divided by 2 will cancel each other out. Then we have 2 sine A
Okay.
over cos A.
Over 2 cos A.
Yes.
Yes.
Over 2 cos A.
Absolutely.
And then we'd cancel out the 2.
Mm-hmm.
Then we're left with sine A over cos A, which is equal to tan A.
Okay, so that would be equal to sine A over cos A. Lovely. So those would cancel over there and we would end up with tan A. All right. So that one was a little bit easier. That's why I had decided what I was going to do with you guys this evening is I was going to do this really difficult one on my own. Well, not do it on my own, but do it as an example. And then give you one that was a little bit easier to try by yourselves. What I think you guys should do is I think you should take a screenshot of this particular question. And I think you should try it again on your own. You can always come back to the video or to screenshots later to check whether you got your answer correct. What I'm going to do is I've got a bunch of questions that I just stuck down at the bottom for just in case. I'm just going to see if there's anything down there that would help us or help you to be able to practice this particular concept. Has everybody taken a screenshot of example 13? Yes, okay. All right, so I'm just going to scooch down here. Okay, another one that would be a good example for you guys to try. Sorry, I know this, I don't want to make this overwhelming here. Okay, but question 5 and question 6. Question 5 and question 6 would also be good ones for you guys to try. So just make this just a little bit larger, and then at least hopefully taking a screenshot. Don't worry about the rest of it. Don't worry about 7, 8, 9, and 10. But get a screenshot of question 5 and question 6. And then you can also use those to practice this idea of getting a trinomial or difference of two squares or factorizing. Okay.